Good afternoon, everybody. I hope that my last podcast on stoichiometry in the notes made some sense to you. What I'm going to do now is I'm just going to go through the first two problems here and show you the steps of stoichiometry, and hopefully this will make some sense that you can continue working on this. Like I've said in class, that this is the most important thing in terms of being able to move forward in this class because it kind of is combining everything all together in one. And yes, I still love this stuff, stoichiometry. It combines the math stuff that I really enjoy along with the science. So first thing we need to do is we need to write a balanced equation. So we have sodium bromide solid. When electric current passes through it, the electric current gives you an indication that it is going to be a decomposition reaction. And it tells us that we have a solid decomposing into sodium, which is going to be a solid, plus bromine, which is diatomic, which is going to be a liquid. All right, now I need to balance this out. So I have 2 bromine, 2 bromine, 2 sodium, 2 sodium. All right, so hopefully you're an expert now at writing a balanced equation. And then the next step that I would say is you need to make sure that you go back and read the question and write down what's given so you can see where you're headed. So we have 10.3 grams of sodium bromide. So go ahead and write that down. And electric current passes through it, yields what mass? Mass is in grams, so this is going to be our X in grams of bromine. Now, for these first few problems, it's going to seem pretty easy because we're going from grams to moles to moles to grams. But as we get to homework 5 and 6, you're going to really need to stop and think about the values that you really need in terms of where your mole map is going. So you heard me mention about the mole map in the last podcast. So we are going from grams of sodium bromide. We're going to change that into moles of sodium bromide. And then we're going to go to moles of bromine. And then we are going to go to grams of bromine. Okay, so the first thing that I need to do is I need to go ahead and I need to look at my mole map, and I can see that I have 10.3 grams of sodium bromide. And I need to divide that out by its molar mass. So I know that 1 mole of sodium bromide, and remember for molar mass now. The one thing that I really want to stress with this is that when you are finding molar mass of these compounds, I do not pay attention to any coefficients that I have added. For this, I just find the molar mass of 1 sodium, which is 23.0, 1 bromine, which is 79.9, and I'm going to add that up, and I'm going to divide that into my mole map here. So you can see that I did not put the 2 in there. We're going to use that in our mole-to-mole ratio, so we do not want to use that in determining our molar mass. So when I add those 2 together, I get 102.9 grams per 1 mole. So again, grams of sodium bromide cancel out. I'm left with moles. So now I'm going to do my mole-to-mole ratio that we started out this section with, unknown over known. So I know that I have 1 mole of bromine to 2 moles of my sodium bromide. And I need to go now from moles to grams. So I canceled out moles of NABR. Now I need the molar mass of 2 bromine. And 2 bromine is 159.8 grams per 1 mole. Okay, so now I'm going to grab my calculator, and remember this is like over 1, so it's 10.3 times 1 times 1 times 159.8, and then divide by the bottom, 102.9, and then divide by 2. I need 3 significant figures, so my answer should be 8.00 grams of bromine. Okay, so what this tells you is that when I take 10.3 grams of sodium bromide and break it down, I'm going to generate 8 grams of bromine in the liquid form. Okay, so let's try the next one. I'll go a little bit faster on this one. And we are going to take solid aluminum, reacts with mercury 1 nitrate. Okay, I'm just going to jot this here for you really quick. You need to remember that mercury 1 exists like this. So when I crisscross these charges and it comes down, that 2 is going to stay there. So it's Hg2 parentheses NO3, and I need 2 of them. So I am not going to reduce those 2's. I'm going to keep them there. And I have a single replacement reaction, so I'm going to get aluminum nitrate and mercury. And mercury is going to be liquid at room temperature. This one is going to be aqueous at room temperature. Now I need to go back and I need to balance this. And in order to balance this, I'm going to put a 2 here, a 3 here, a 2 here, and a 6 here. Okay, so then go back and make sure you read again. So I have 5.4 grams of solid aluminum. So 5.40 grams of solid aluminum reacts with how many grams, X grams of mercury 1 nitrate. So my mole map is going to be grams of aluminum to moles of aluminum. And you can look at your mole map to figure out what you need to do with that. Then I'm going to go to my mole to mole ratio, moles of mercury 1 to grams of mercury 1 nitrate. Okay, so that's where I'm headed. So I'm going to do the same thing. I'm going to take and start with what's given, 5.40 grams of aluminum, time sign fraction bar. Again, to find the molar mass of aluminum, it is just 1. I am not going to use the coefficient out in front. So I have 1 aluminum, so 27.0 grams of aluminum in 1 mole of substance. Grams are canceling out. And now I'm going to do my mole to mole ratio. And so unknown over known. So I look at my unknown, I have my X here, so I have 3 moles of my mercury 2 nitrate to 2 moles of my aluminum. And then I'm going to find that I need to go from grams to moles, so I need the molar mass. So again, you should be doing the molar mass of that mercury nitrate. You should be thinking that I have 2 hydrogen, I have 2 nitrogen, I have 6 oxygen. Again, I am not using that 3 out in front, just the molecule itself. So 2 hydrogen, 2 nitrogen, 6 oxygen, and when I added that all up, I got 525.5 grams in 1 mole. Checking my units, I can see grams of aluminum cancel out, moles of aluminum cancel out, moles of mercury 1 nitrate cancel out. I'm left with grams, and I plug it all into my calculator, and I want 3 significant figures. So this should be 158 grams of my mercury 1 nitrate. And there we are. Okay, so that is the first 2 problems, and we can take any more problems in class 2 if you have any questions. So good luck. Please work hard on this. It'll be good practice for not only this chapter, but for the rest of the semester if you can get all of this done. Have a wonderful night, and I can't wait to see you in class.